아키아에 대해서 실무에서 많은 경험을 갖고 계신 분이 이제 론이라는 분이 세미나를 하시는데요. 지금 국내에서 이 아키아에 대해서 잘하는 분이 별로 없습니다. 저도 잘 모르겠고. 근데 이것이 아마 이제 최초의 아키아에 대한 세미나가 아닌가 싶은데요. 지금 특히 이제 사우스 아프리카를 위주로 해서 현장에 적용됐고 그런 예를 지금 여기서 보여드릴 거니까 이걸 보고 우리나라의 어떤 방향으로 이걸 적용을 하고 이용할지 생각해 볼 수 있는 계기가 됐으면 좋겠습니다. 오늘 말해주실 분은 로니 엠바스라고 하시는 분인데요. 거의 물 관련된 특히 이제 바이오로지컬 웨스트 분야에 15년 이상 경험을 갖고 계신 엔지니어입니다. 특히 이제 이쪽에 아키아를 이용해서 실질적으로 핫스토리장을 업그레이드 시키거나 효율 향상시키는 공정의 일을 많이 하시기 때문에 아마 오늘 아마 저도 영어를 잘 못하기 때문에 제가 통역이 좀 잘 안 떠고요. 천천히 하시면 아마 대부분 알아들으실 수 있을 거라고 생각을 하니까 천천히 하도록 부탁을 드리고 세미나를 시작하도록 하겠습니다. 그러고 이제 나중에 질문은 여기 영어 잘하시는 분이 김 선생님도 계시니까 통역이 충분히 되리라고 보고요. 질문하실 거 있으면 메모 해주셨다가 끝나고 나서 질문을 해주셨으면 좋겠습니다. Okay, now running your turn. Everybody here maybe can be understand English, but if you speak slowly and clearly, no problem here in English. So, thank you. Can you share your slides?
Professor Tom, thank you very much for the introduction. Gentlemen, thank you very much all for coming. I realize there is a language barrier, so please at any time interrupt me and I will explain, or maybe Professor John or Mr. King will be able to translate. I will be talking on how to enhance your sewage treatment works. How do you get the most out of your sewage treatment works? And the way we see it is by using Archaea. Archaea is the key to wastewater treatment. And how does it all fit into the system? If you're looking at wastewater treatment plants, what is a sewage treatment plant? Most people will tell you it's an activated sludge basin, it's a lot of concrete, there's aerators, there is electricity and all the rest of it. But if you look at a biological process, the essence and the focus of a process is not the concrete, it's not electrics, it's not the mechanicals, it's the biomass. How do you get the biomass to function optimally? How do you make them work harder? So how does it work in nature? Nature was always been composed of two components. You had your eukaryotes, which was basically your algae and your fungus, and you had your bacteria. And everything was basically divided into those two domains. Humans, just for the sake of interest, they fall on the eukaryotes. And about in the 1980s, there was a gentleman by the name of Carl Weiss. And he basically discovered a third life form. And the reason why he only discovered it was we didn't have the equipment to really see or find them, discover them. They've always been there for millions of years. But there were certain environments where that were always considered as being sterile, like at the sea bottom floor where you had hydrothermal vents. under 350 degrees Celsius, you're looking at 7-8% salt concentration, maybe even higher. Very high in sulfur, very high temperatures, low pHs, and they've now discovered that it is actually teeming with life. But not life as we know it. It's not bacteria, it's not plant and animals, it is archaea living there. And they found that these archaea, as they are now looking more and more into marshes, into everywhere, they are finding more and more of these archaea established even in oxygenated areas. Alright? So in the absence of any of these species, your recycling of carbon, nitrogen, phosphorus, whatever, will cease. And if archaea were not present, we would have been up to eyeballs into waste. So the natural way, how did nature always degrade waste? And this is how I see it. If you're looking at the simplest way of waste sewage works, you're looking at an oxidation pond system, where you have organics coming in, your biological material settling to the bottom, you have your organic waste being degraded into methane, ammonia, and all of that, CO2, and they actually become a food source to your bacteria. They produce CO2 in turn, and in the oxygenated top zone you have your algae consuming the CO2, providing the oxygen to the bacteria. When these organisms die, they settle to the bottom, and they in turn are then decomposed into methane, CO2, and the whole cycle continues. You have sunlight, you have wind introducing oxygen and CO2, and this system is in balance. And if you have, in our country, South Africa, we have lots of oxidation pond systems, and if they are designed properly and correctly, on correct loadings, they will function properly for years, for even 100 years, without a problem. But, especially in Korea, there is a problem with space. Everything has to be compressed, everything has to be optimized, there are too many people. So man has done away with this kind of setup, and they have basically what they've done is they've replaced the oxidation pond system, put it into an activated sludge system, and they've introduced oxygen by using aerators instead of the algae. If we're looking at anaerobic fermentation, you're looking at the glucose is converted to acetate. Alright, that's the first step, acid formation. However, your byproduct is H2 formation, and obviously your pH drops. And if you don't remove your hydrogen, you have a problem with anaerobic fermentation. So what happens if you have a buildup of hydrogen and you cannot remove it quick enough? You are starting to produce other higher order acids, propionic, butyric acids, and they are more difficult to break down. The only way to really make this system function properly, and organisms prefer to break down glucose to acetate because it's more energetically favorable for them. They get the most energy out of it. And the guys that do that work is archaea. The methanogens have always been classified as being bacteria. They are not bacteria. They are archaea. They've been reclassified. And the interesting thing is, if you're looking at an anaerobic digester, the population of archaea in the digester is only 4% of the total. The rest of it is all bacteria. The only thing bacteria do is converting your glucose to acetate. In other words, converting it, not converting the COD to anything, you're changing the structure from glucose to acetate. So you haven't